Hi, welcome to SUSECon and welcome to session PROD 1249. We're going to be talking about Linux high availability, but with a patching context to it. So we're considering the idea of balancing your security posture with the needs of the business to have services continually available. My name's Brian Petch. I'm a sales engineer, pre-sales consultant for SUSE in the UK and Ireland. I've been with SUSE about five and a half years, that kind of time. I spent most of my time working on the traditional SUSE products, but getting involved in a few more Rancher and New Vector exercises now as well. So our agenda for today, we're going to look at patching, the need for it, and then the challenges that come with that. And then we're going to move on to high availability clustering. Again, a brief review of HA clustering before we move on to putting those two pieces together, again, trying to sort of balance the needs of different parts of your organization. And lastly, we're going to look at the rolling update process, which can help us with this challenge. And at the end, we'll have a short demo of actually seeing some of this stuff live. So Linux patching, you're probably doing it already. I certainly hope you are. Why should we be doing this? Basically, Linux, which includes SLES, SUSE Linux Enterprise Server, it's built from many different packages. So a SLES 15SP4 default installation is over 600 packages. For the SLES for SAP installation, we're over 1,000. So there's lots of components that build up a distribution. And those packages change on a very frequent basis, often daily. And some of those changes are for updates and new capabilities, so adding new pieces of innovation, those kinds of things. But a lot of it is fixes, so bug fixes and potentially security fixes. That may include updates to the kernel or just to the packages themselves that built the distribution. So given this security context of bug fixes and security fixes, we should really be patching. We should all be doing it, and often. And in terms of doing that, there's tools that can help you deal with the patching workload. Particularly SUSE Manager is a good one to point out. You've probably heard of this already. There are many sessions in SUSECon that will be talking about the capabilities of SUSE Manager. It has a great deal of capability in that product, but its primary core purpose is really around managing the workload of delivering patches and updates to your entire estate. So not just your SUSE Linux infrastructure, but other distributions as well. So a great tool. So highly recommend having a look for all the sessions around SUSE Manager. So we've said that we need to do patching, but it costs us time, where time means downtime for your service. And most customers I've come across deal with this by allocating a service outage window in which to do the patching work. So it varies from customer to customer. Some customers will do take out half a day, some will take a day, some will take a weekend, where they take the service down, do patching, and then bring the service back up again. So that's a kind of a necessary evil, and it's an essential task, but it does cause an interruption to the business. So what kind of topics, tools can we use to deal with service interruption? The classic one is high availability clustering, or HA clustering. It's a very general and commonplace approach to deal with traditional applications and improving their availability. When I say traditional applications, I'm talking about non-cloud native applications. So traditional apps basically expect the infrastructure underneath them to be there all the time. Cloud native applications are often designed to tolerate some level of disruption in the infrastructure, or there's associated other pieces that can help deal with that. But for traditional apps, they expect infrastructure to be there, and if it's not, your service is down. So HA clustering has historically been often considered as being dealing with major failures. So perhaps a server failure or a data center failure or power failure, those kinds of things. I always like these images on this slide. So obviously the one showing a data center on fire, that would be pretty bad for your service. The other picture is a meteor that exploded over Russia in about 2015, I think it was. It blew up in the atmosphere. The explosion caused a big bang and blew out a lot of windows in the area, but didn't cause much more damage than that. You could imagine, though, if that had actually got to the ground level and hit your data center, that would be pretty bad for your service. It would certainly kill it. So HA clustering is often targeted at dealing with those kinds of disasters. But to be honest, those kinds of events are very, very rare. We don't hear about those kinds of things happening very often. So what is more common is planned events. So things like wanting to add additional memory to a server or doing a CPU upgrade, those kinds of things, but also patching. It's one of the routine things that we do all the time. So if you have critical systems that have a very tight service level, so they need to be up a lot of the time, very little downtime allowed, why not look at using clustering to actually reduce that downtime window and reduce the downtime window for patching? This session, in fact, is based on a real customer project that I'm involved in at the moment. It's an ongoing customer exercise, but it's an interesting example because in the customer case, they were getting pressure from their security team to patch more frequently. Again, they had a pretty strong security posture, and they were already doing a good job of their patching. But the security team were pressuring them to patch more frequently, again, to keep on top of security fixes in their estate. Conversely, the business stakeholders did not want to take any more downtime for the Windows to install those patches. So this is actually an SAP environment. So the SAP basis team were kind of caught in the middle. So they had the security team on one side saying, please, can you patch more frequently? And then we had the business stakeholders saying, no, we're not going to take any more downtime for this. So they came to us and we had some discussions, some conversations around it. And we kind of asked the question, can we use HA clustering to minimize the downtime that you need to suffer in order to implement patching? And the answer is yes, we can minimize that downtime because there is a capability in clustering called rolling updates. So we'll have a little look at that. But before we do, we'll start with a quick look at a stereotypical HA cluster architecture. So here we've got, again, so a typical HA architecture, we've got an active, passive, 2-node or 2-server cluster. Server A is the kind of primary server, if you like. Server B is like a standby or a failover server. In terms of the service that is being presented here, that's being delivered through this VIP, this virtual IP address at the top of server A. Sometimes it's referred to as a service address. But that is the mechanism by which the service, in this case a database, is presented up to clients or application servers or whatever actually needs to consume the service. In the middle, if you like, we've got a pacemaker cluster. Pacemaker is the upstream open source project, which is the core of the SUSE Linux HA product. Obviously, we do lots with it, but it's based on the pacemaker upstream project. And then as part of the design, we need to replicate the database from server A to server B, so it can actually take over the service when it needs to. And again, this is an SAP environment, so we're using HANA system replication. It's a HANA database. So we're using HANA system replication to essentially copy the data between server A and server B. And of course, the idea is that, if the power fails to server A, for example, or the cluster will detect that failure, and then server B will automatically restart the service and everything continues. That's the standard kind of approach with this kind of design. So if we look at the rolling update process and just see how that works, our first step is actually to turn off the cluster monitoring. So again, with an HA cluster, it monitors a large variety of parameters in the servers and the applications to make sure they're behaving properly. So because we're going to take action on the servers, we want to disable that for a period. So our first step is to basically put the cluster into maintenance mode. So please stop monitoring all of our servers and applications. Once we've done that, we can actually patch the standby server. So again, both servers originally at patch level 1, then we move the server B up to patch level 2. We'll update that. And again, while this is happening, the service continues to operate through that virtual IP address or the service address, so that clients don't see any interruption to service at this point. Once our server B has been patched, and we've tested it and we make sure everything's okay and behaving the way it should do, you may want to take a day or so to do that. Again, just make sure everything's tested properly. We can then actually move on to the next step, which is to re-enable the cluster monitoring. So we turn the cluster back on again. Then, again, once everything's steady, again, we've got differing patch levels now, patch level 1 on A, patch level 2 on B. The next step is to actually manually relocate the service from server A to server B. So we actually use cluster tools to do that. So we get the cluster to relocate the service. And as you can see, the virtual IP address moves from server A to server B. So the service, the database service in this case, is actually now being presented through server B, through the same virtual IP address. So clients and application services, etc., see exactly the same thing. There is downtime associated with that move. Again, we're essentially shutting down the database on server A and then restarting it on server B. That's obviously an interruptive thing, but that process takes a matter of minutes. It's not a long thing, so it's very, very quick exercise. So now we've got our service hosted on server B. We can actually put the cluster back into maintenance mode again. So that then says we're going to do the next step of this update. So we tell the cluster, stop monitoring things. Once that's been done, we can actually patch server A. So again, our service is being provided through server B. So clients are, see no difference, no change whatsoever. But we patch and update server A, and that could mean, a reboot. Often updates require a reboot of the server to actually implement them. So we can do all of those kinds of things without affecting the service at all because it's running through the other server. And then again, once we've done that and we've done some testing to make sure it's okay, we can actually re-enable the cluster again. And we're now at the point where we've updated both of those servers to patch level 2. So we've completed our rolling update. And the only downtime for the service in that process was actually the move of the service from server A to server B. So the consequence of all of this is that clustering allows us to decouple the patching time, or the time it takes to do the patching, from the actual downtime required for the service. So the service downtime is literally just the time it takes to manually fail over the service from one node to the other. Typically, that's just a few minutes to do that. I will say it's not all kind of roses around the data center. Clustering does add complexity. we've got more servers to manage. There's differing commands involved in manipulating the cluster. But if you've got a service which requires high availability, can suffer very little downtime, clustering can really help to actually deliver that. So I've been talking about this for about 20 minutes or so. Let's now drop out into a demo just so we can actually see some of this stuff in practice. So what I've got here is I've got logon windows into two servers. I've got if you can see this with this color font, I've got two servers, SAPDB1 and SAPDB2. So they are literally, it's a strict analogy to the slides we've just seen with the rolling update process. So I've got two nodes, SAPDB1, SAPDB2. Our SAP HANA service is running out of server 1, and server 2 is our standby or failover database. We can actually look at the cluster. We can see what the cluster is doing. So there's a command crmmon for CRM monitor, a cluster monitor, essentially. I'm not going to drill into the fine details of all these cluster commands. That's a much longer story, certainly part of a training course. But we'll see some of them used here. So crmmon, monitor, tells us that we've got two nodes in our cluster, SAPDB1 and SAPDB2. It also tells us that we've got a HANA database running on the system, on the cluster, for which SAPDB1 is currently the master location, the primary database, if you like. The way that HANA databases or HANA clusters work is that you have an active database on one node and a standby database on another. So that's part of the design as well. And again, our standby is running on SAPDB2, as we can see there. The other thing which is really interesting in this design is we've actually got our service IP address. That's our cluster IP address, and I can show you that. That's currently running on this node on SAPDB1. So there's our cluster IP address. It's separate from the standard NICs. So we're running on a very different address for that's our service address. And another thing to just show you very briefly is I mentioned HANA system replication is being used to replicate data from server A to server B. Again, don't worry about the fine details, but what we can see is that of our databases, SAPDB1 is promoted, so it's kind of the master database, and then SAPDB2 is demoted, it's our standby database. But the most important thing here is this thing SOK. That means sync is okay. So your HANA system replication is okay, it's up to date, it's working fine. And our primary is on SAPDB1. So that's the kind of the basis of our cluster, our basic environment. The other thing we've got is I've got on SAPDB2 currently, I've got a login for the HTTP ADM user. That's the HANA database administrator account. And I've got a short test script that I've put together just to help us with this. Basically, all I'm doing is I'm just making some database connections over the network to say, go into the database and then read the username and user ID from the SUSE users table. So it's just a remote database connection and read, essentially. And then I loop over that continually. So just keep looping over that one. So it's a constant test of the database, a fairly simplistic one. So I can actually just run that, and it just pulls out the usernames and user IDs in the database. It does it quickly because it's HANA, so it's all data in memory. And then I'm looping over this, so we see run number 4 just gone through, run number 5, that kind of thing. So it's a simple test of accessing the HANA database through the cluster service address. So we'll leave that running. So in terms of our rolling update process, we need to first move the cluster into maintenance mode. And again, there's a number of different mechanisms or command types that you could use for this, but don't pay any detail to that. We can, that's a subject of some training. But I'm going to take a simple approach. So I'm going to put the entire node, the whole node, into maintenance mode. So it basically says, for the cluster, just ignore what happens on node 2 right now. So I'm saying CRM node maintenance SAP-DB2, put SAP-DB2 node into maintenance mode. If we run our CRM mon again, as I execute this command, you'll see we've got 2 nodes online. Straight away it goes into maintenance mode, and it also shows our various services become unmanaged. So that, again, this means the cluster is not monitoring them. So now I've got the database in maintenance mode. I can actually do the patching exercise. So in this case, we've got SAP-DB2, so I'm just going to do zipper patch. In fact, I'm going to go the whole hog. I'm going to say zipper up, so it's update everything. That brings us completely up to date. Strictly speaking, this should be part of a lifecycle management process. So patches should really flow between dev to test to production. Again, that's something that SUSE Manager can help you deal with. There's a function within SUSE Manager called Content Lifecycle Management that's set up to do exactly that kind of task. But as you can see, there's a number of updates and patches that we need to install to bring us up to date. So let's go ahead and install those. It's not too many, so it shouldn't take too long. Of course, while this is happening, this is the standard, patching update process on SUSE Linux. Our database queries are still running away. My counter is incrementing, so just that loop is still working. So there you go. That patch has that patch has run. Patching process. And again, we could, some patches do need a reboot to enable them. I'm not going to do that here, but just for the sake of time. But our patching is essentially complete. So now that we've done the patching process, the next step of that is to bring the cluster back online again. So start monitoring. As you can see, we're still unmanaged in our CRM monitor. So if I bring the node back online, it's the whole node, so it's CRM node ready. Again, everything's being managed now. We can see CRM mon is saying, yep, I understand everything. My node is online. I'm monitoring everything. So the cluster is back in action again. Okay. So the next thing we need to check, or the next step of the process, is we've patched SAP-DB2. Our service is still running on SAP-DB1. Again, our little test script is still running here. So now we need to go and patch. We need to move the service across to SAP-DB2 and then patch SAP-DB1. So in order to do that move, to move the database, what we need to do is 2 things. The first one is we need to check the replication state. So as we can see, we've got this lovely SOK measure. That means our replication is functioning and up to date. So that's fine. So that's good. And the next thing is we relocate the service, again, using cluster commands from SAP-DB1 to SAP-DB2. Again, don't worry too much about the command detail. That's beyond what we're getting into here. More the fact that we're just taking using cluster commands to actually move the service from server A to server B, or in this case SAP-DB1 to SAP-DB2. Thing to notice is it takes the service down. So in our test script, it's running now, but we'd expect it to be interrupted as the service is taken down. So let's run this. Straight away, we see some action in our cluster monitor. And yes, look, in the test script, we're seeing connection failure. So the script is trying to go out to the service address of the cluster through to the database, and it's saying, no, I can't do that. Not available. In our CRM monitor window, we can actually see that our IP address, the service IP address, has now been migrated across to SAP DB2, node DB2. And also, you can see it's promoting our HANA database on SAP DB2. So it's in the process of starting it up. And look, our test script has just jumped back into life. So that was our database back up again. It's restarted on SAP DB2. So how long did that take? So there's all the failures. Let's scroll backwards. So the successful run before the move was at 11:58 on my clock. And then it fails as it gets relocated to the other server. And then it fires up again and succeeds. And that's at 11:59. So it took about a minute to fail the service across. Again, this is a small database. It's just a test database. The more data you have, the longer it will take. So typically it's a few minutes, but again, it's a few minutes to move that service from SAP DB1 to SAP DB2. It's not half a day or a day's downtime to deal with this. And there's our service running away. My queries are running against that database, again against the cluster IP address. Again, I've mentioned the cluster IP address. Let's just prove the point. So there's our cluster IP address. That's responding nicely. And that's what we'd expect because our test script is basically going out over the network to the cluster IP address to connect to the database. And we can see in our cluster monitor that the master database is now running on SAP DB2. So we've moved the database across. There's a second step. I need to just execute that. And essentially what that's doing is that's saying, please restart the standby database on SAP DB1. So you'll see it's starting up here. So again, that's kind of no impact on our service. That continues to run. That's good. So that's all started. So now again, we've got our master database running on SAP DB2 now, and then the standby database is running on SAP DB1. So we've taken it from SAP DB1 and moved it to SAP DB2. So the next step is to patch SAP DB1. So the first step of that process again was to put the node into maintenance mode. For that purpose, I'm actually going to stop this. So I'm going to start it again here so we can actually watch what happens with the database. So again, cluster commands can be issued on any node in the cluster, so you get the same result. So that's the same information just on running from the SAP DB2 node. And then I'm going to put the SAP DB1 node into maintenance, so we'll see that appear in the monitor window. So there we go, SAP DB1 has gone into maintenance mode, and those resources are then unmanaged by the cluster. That then means we can operate on the other node without fear of interacting in any bad ways. Meanwhile, our service continues, of course. So let's do that update. Let's do the same as before. Zipper up, standard SLES patching mechanism. Again, it doesn't take very long to do that one. I haven't got many updates to do. Yes, please. So it zips through those. Super, that's quick. So that's our patching done. And again, our service is, oblivious to all of this. So having now done our patching, we can bring the node back online. So move it from maintenance mode back into cluster monitor mode, if you like. Do that one. We see it reappear in here. Started monitoring. So the cluster is monitoring our node and its resources again. So so there we go. So we're now in a position where our two servers have had patches and updates applied, and we've the only impact to the service was the time it took to do that failover from SAP DB1 to SAP DB2. So 60 seconds in my case, probably a few minutes in a real world case, but again, not very long at all. So with that, I'll just pop back to the slides. So to summarize it, patching is of course really important, especially from a security standpoint. Keeping on top of security fixes is becoming more and more important in almost all organizations. But the process of doing that is actually interruptive to your service. So you have to take it down to do it. High availability clustering can actually help with that. It adds a level of complexity. As you can see, we've got more infrastructure in place. Some of the commands are very different. If you've not seen clustering before, you wouldn't recognize any of those. But if you have a service where reducing the patching downtime is important, you need to keep the service available as much as possible, then HA clustering can basically allow you to reduce the time required to do your patching to little more than it takes to actually just stop and restart the service. In terms of how do you get the tools, clustering capability is available as an add-on to SUSE Linux. So the SLES HA extension or high availability extension is available from SUSE. That provides the clustering capability. And then if you're running an SAP workload, the SLES HA extension is actually included as part of the SLES for SAP bundle. So it's very commonplace that the SAP workloads are mission critical. So really have very little downtime allowed. So they're very often clustered. So we bundle in the HA extension with SLES for SAP because it's so commonly used. There's a few references, a little bit of bedtime reading for you here. Much of this discussion was based around the blog article at the top there. You can read some more about the HA extension on our website. Lots of documentation there. And I'd also highly suggest having a look at SUSE Manager for dealing with your patch and update management generally. It is a very capable tool. So with that, I'll say thank you very much for joining this session. I appreciate your attention and do enjoy the rest of SUSECon 2023. Thank you.